Thank you, Amy. And so I'm an assistant professor in the Department of Mechanical Engineering here at the University of Michigan in Ann Arbor. My research group is called the Global Design Lab, and we really take a look at combining design optimization and complex system design with thinking about these really large sort of complex socio-technical systems. And I wanted to do something a little bit different today. I wanted to talk about multidisciplinary collaboration, and I really wanted to sort of evangelize a little bit for anyone in the audience that, wants to work on these types of issues, but perhaps is, could be a client of CGEN in the sense of working with you guys in a collaborative way. I want to explain what some of the benefits I have seen in terms of my own mechanical engineering, sort of strictly within our siloed domain benefits within the discipline that come from working on these larger issues and really trying to understand how we can work together in a team. So the motivating question for me when I'm working on these, and I think Evan put it, really greatly, much better than I can, is how do we create solutions which actually reduce poverty? So if we really want to have an impact and we care about impact for our engineering, how do we go about creating and engineering these solutions to do that? I'm going to talk about one project, which is an ongoing project we started in 2017 in Thailand. And that's working on informal e-waste, working with informal e-waste recyclers in Thailand. This is just a picture of the e-waste that has been collected, delivered to the demanufacturer's house, the recycler's house, and they go through and separate.
Sorry, I noticed that your slides are not full screen. I'm thinking that we're not seeing the same screen that you're seeing when you're going through your presentation.
Okay, there you go. Possible.
Yeah.
All right,
now
stop sharing.
We're never seeing that slide yet.
And let's try that again. Right. I'm going to just share my entire screen, and we'll see how that, that takes care of it. Can you let me know if this is now full screen?
Yeah, now it's full screen. I see it all.
Perfect.
Awesome.
Yeah, sorry about that. Thank you. We live in the future, but we also don't. So what we see here is just an informal e-waste recycler. And I think, when we think about it traditionally, I just want to take you through sort of the scale at which we want to think about this. Many projects, and we think about technical performance as engineers, we may be thinking just about the informal e-waste recycler. In this case, because they work in informal firms of 3 to 5 people, you often have employers and employees, right? And so this may be an important interaction if we want to understand what is the impact on whether it's health outcomes or poverty or their finances. We're going to want to understand what is this interaction within the firm. If we go a little bit larger, we say, well, the e-waste collector, the mid-tier recycler that they're selling their supplies to, any intervention that we might want to engineer, we're going to have to understand the interactions between all of these stakeholders. And if we continue doing the stakeholder mapping, you can include larger recyclers, the municipal waste management, the end user who's producing the waste, the government ministry who is regulating the system. If we shrink it down and go even bigger, we might have the manufacturer of whatever that e-waste originally was. And certainly this is an opportunity for thinking about how we might regulate those in terms of thinking about end of life, and people do that. You could have other government ministries, the health NGO, like who we were working with, community members. And when we do all of this, we can think of that as like the recycling system, right? And if I'm a mechanical engineer and I'm interested in looking at the supply chain and how this recycling happens, and then engineering an intervention, I'm usually keeping all of my sort of performance metrics and my analysis within this set of stakeholders within the recycling system. But you can see as we started to really try and think about what would be the impact on poverty, we were starting to get into other things, such like the health system. So the public health of the community members, as well as the e-waste worker themselves. And then also the economic system. So when we started to think about, well, would this intervention actually reduce poverty? You have to think about what are some of the structural issues within that recycling system, but also the larger just market system that it's existing within in terms of how much money they can make and what are their opportunities within their own economic system. So when we think about, and this is just three possible systems that you might, overlapping systems that you might think about to try and really understand the impact of any solution that you're engineering. We could think about the education system, and there's just many interlocking and complex systems that affect the ability and the impact of your engineered small intervention that you are doing with this informal e-waste recycler. So if we want to make predictions as engineers of what this impact is going to be and make design decisions to try and have a better solution, we really have to try and understand some of these larger structural issues, or what I would call the system level view of that intervention. So if we get back to this seems really complicated now, me as an engineer, and I think what you've heard from a lot of the other speakers or will hear is we're working with a lot of other people to do this because it's hard as engineers to try and model or make predictions or really understand in any way all of these interactions at the system level. So for me, I want to echo what Evan said. I think we need to make poverty reduction an outcome of the engineering tools that we have. And right now, I think we're really focused on technical performance. And in order to do that, I really think we need to have multidisciplinary teams and really be reconciling and connecting methods across these areas, as you heard in Evan's talk, that they're currently doing. But I want to encourage everybody to be working in this way, in the way that CGEN is. So this is a perfect forum for that. So to talk about, okay, we want to have these multidisciplinary teams in global engineering. I want to go through this one project on informal e-waste recycling and sort of talk about what are the benefits from a research perspective in terms of the creation of original scientific and engineering knowledge that come from working in this multidisciplinary manner. So if we want to think about these complex systems and we want to interact with other disciplines and team members that have wildly divergent views and disciplines and methods, how does that benefit me as a mechanical engineer and really a design researcher? And what potential benefits can I get from working in this? Now, obviously we have papers and you can hear, Evan's discussing just the sheer number and breadth of the type of scholarly work that you can produce. But I think there's some mechanisms that I would like to bring up to encourage you to plug into the type of work that CGEN is doing and the type of work that we're doing here at Michigan, that I think can really make your own work within whatever discipline you are much stronger because you've interacted in this multidisciplinary way. So the system level view, as I said before, in this informal e-waste recycling, we had the recycling system, we had the health system, and we had the economic system. And because of just a funding structure that exists here at the University of Michigan that encourages 3 schools, investigators from different schools to work together, they give you some cost matching funds when you do that. We had a team that started with the School of Public Health. So Dr. Rick Neitzel over at the School of Public Health contacted me and said, hey, I've been working with this community of e-waste recyclers in Thailand, but I'm not sure what to do. And we'd like to design an intervention. We know you work on this global engineering type of projects. Would you be interested? I said, yeah, that sounds great. But because we were working also interested in understanding the real impact in terms of profit and the impact on these small informal firms, we also wanted to bring in a development economist. So we got Professor Adavariu, who's from the University of Michigan Ross School of Business, who's a development economist. And we all started working together on this informal e-waste recycling project. And the problem statement, and this was informed by working with all of our collaborators, was the disassembly of the stator. So what you can see here, this is a stator from a motor of a fan. It's very similar to ones that you would find in a compressor for a refrigerator. This is one of the most common things they demanufacture or recycle because these copper windings are very valuable. So copper is extremely valuable. And what they do is they use a lawn edger blade. What you can see this person holding with the cotton gloves is a lawn edger blade, and they hammer it through between the plates of the stator in order to cut it in half and then be able to extract the copper, be able to pull the copper out. Now, this is really hard. I've done it a bunch of times myself. It hurts your hands a lot, and it's a really slow part of the process. So they're really thinking this is a good problem statement for this. So I'm just going to take you, I'm not going to discuss the details of everything that happened, but just take you through what happened in the research project, and happy to talk later about details of these different things. But the first thing we did was to design the intervention itself. So what should we do? We know that this e-waste recycling is a public health problem because of the School of Public Health had done an evaluation initially before coming to us. And so we did a needs analysis. So we went out to Thailand with my grad students and people from the School of Public Health and our collaborators at Mae Fah Luang University from Chiang Rai, Thailand. And we went and did a needs analysis. We then did a conjoint analysis, which is a tool within design, but also for marketing, in which you try and find what are the preferences of the users for different features of a product. And we actually, so this is us conducting the conjoint analysis, we were able to do a somewhat novel thing of using physical prototypes to do the conjoint analysis, and that's what you see there. And then we did, what's really my wheelhouse, which is design optimization, in coming up with, what is the best design or the features, the values for these features, attributes of the product for this, at the end of the day, a knife with a handle and a guard in order for cutting through these stators. We ended up producing 150 of them. You can see them here in our small scale pilot. And then that's where the development economists took over. And the development economists did what's called the Becker-Ducrot-Marshak auction, which is a randomized second price auction. And they were looking there to estimate the willingness to pay in a more rigorous way than happened in our engineering techniques. And to do that, they compared, you get people to do an auction between money to buy household goods at prices you would find in the local market versus money that you bid on the knife that we produced. And it turned out that the willingness to pay was about 3 times what a chisel, the edger, or a similar chisel would cost in the market. So that was really promising. And then they did a randomized control trial coming out of that auction, because it actually produces a randomized treatment group or randomized uptake, and you can control for willingness to pay. And so we were able to look at economic impacts at 1 month later. We did a survey, and we were going to do more until we were supposed to go back in March, actually, but of course we then had COVID happen. So this is still an ongoing, we're going to eventually go back and do further analysis. The public health team did an injury risk analysis at the beginning, and then did a randomized control analysis based off of that, again, Becker-Ducrot-Marshak auction with the randomized uptake. They were able to look at health outcomes based on us just changing what tool they were using. So, we could go in depth, and I could talk for a long time about the project itself, but I think what I wanted to get across to you guys today was, what are the potential benefits if I'm a mechanical engineer of collaborating in this way? So we have these sort of 3 groups here, and I'm here in mechanical engineering doing my design optimization, doing product design, those types of things. And what I really saw is the interesting part of doing these multidisciplinary collaborations is how the different research questions from the different disciplines interact when you're working collaboratively. So generally, I'm thinking about, does it meet functional requirements? Can we improve technical performance in some way? The public health group really is thinking, will population adopt it? Does it improve health outcomes? How do these things, what is the actual impact in terms of health of any intervention? And the development economists are thinking, at what price will a person buy it, and what incentives exist within these interactions? So they're really thinking, why and will a person buy this, whatever intervention it is? And by working together all at the same time, we were able to sort of come up with new research questions. So based on some of the interactions and incentives identified by development economists, we came up with a novel way of measuring agreement on functional requirements across multiple stakeholder groups. So thinking about, does this product satisfy both the employer and the employee in these informal firms? And this is an issue that I would have, not considered and just gone with whoever is using the end tool, but was brought up by the development economists. And for the public health and development economists, they really, in general, in my experience, and I'm going to broadly generalize here, really think about interventions that are already existing, right? So they have a lot of techniques for thinking about already existing interventions. And what we were able to do is say, how would we modify these techniques and come up with new methods of predicting the implementation, the adoption, the public health outcomes, if we can redesign the intervention while you're evaluating it, right? So they moved from evaluation techniques to generation techniques. We also were able to, in doing this, come up with new methods. So, you know, these interactions between implementation science, between the RCT analysis and Becker-DeGroot-Marshak auctions and design optimization, by doing them all at the same time and knowing what the other methods needed as inputs, we were able to change our methods and we think get a better answer. So at the end of the day, what are the benefits? So if you have these three areas and we're all collaborating together, the first thing I think is you get new research questions. So here we talked about conjoint representations, and this was between mechanical engineering and development economics. And we submitted a paper to development engineering based on that. We also came up with a new, as I told you, a new method for looking at these stakeholder agreements called the stakeholder agreement metric. This was invited, became an invited submission to the Journal of Mechanical Design. And we also think that we got a better answer in terms of when we went back a month later, everybody was, a majority of the people were using the intervention that we produced for our pilot. So just to finish up with how do we create solutions with reduced poverty? I think the answer here is multidisciplinary global engineering teams. And I think not only do we get solutions which we think have a better chance of having an impact and actually reducing poverty, but I think we do better mechanical engineering and better scientific work within whatever discipline you are by doing this type of multidisciplinary work. And with that, I'd like to thank you and move on to the next speaker.